Solving linear inequalities algebraically. So we showed you how to solve a linear inequality using test points. And the main reason we wanted to show this to you is because you're actually going to be using test points to solve more complicated types of inequalities later on. And we want to show you how to do it with one of the simpler types of inequalities first. But test points take a while to do. It's not the most efficient way to solve this type of problem. So in this video, what we're going to show you is how to solve a linear inequality algebraically in a way that doesn't require test points, and it can be quite efficient. The idea here is that we're going to solve these inequalities just like we would solve a linear equation by isolating the variable. So here's an example. If we want to solve 9x is less than 54, we divide each side by 9, and we get x is less than 54 divided by 9. That's in our 9 times tables. That is 6. So x is less than 6 is a solution to that inequality. Let's do this next one. We're going to solve this again very similarly. Just as though it was an equal sign, what we would do to isolate the x is to move that constant term over. So we have 2x is greater than or equal to 9. And then we divide each side by 2, and we get x is greater than or equal to 9/2. And there's our solution. There is a trick that we have to watch out for, though. If you ever need to multiply or divide by a negative number, in order to solve an inequality, then you must flip the inequality in that step. Here's an example to show you what we mean by flipping the inequality. If we were to have this inequality, negative x is greater than 10, well, we need to isolate the x. So in order to do that, we divide each side by -1. Or you could also multiply each side by -1. Either way, that would remove the negative from the left-hand side and move it over to the right-hand side. But when we do that, we must flip the inequality. So negative x is greater than 10 becomes x is less than -10. But why? Why is it that we need to flip an inequality when we multiply or divide by a negative number? There has to be a reason, and there is. The best way I have found to answer that question of why is to look at a really simple inequality like 1 is less than 4. We know this is true, and we can look at the two numbers on a number line. 1 is definitely less than 4. Here's +1 and +4. But what happens if we divide each of these numbers by -1? What if I take 1 and divide it by -1, and I take 4 and I divide it by -1? Well, then they become -1 and -4. And they flip over to the other side of 0. So -1 becomes, 1 becomes -1, 4 becomes -4, and look at what has happened to the order of these two numbers. Before, -1 was definitely less than, 1 was definitely less than 4. But when we're talking about -1 and -4, well, look at what's happened. -1 is larger than -4. So if we divide each side, so now we have -1 and -4. if we divide each side by that negative value, we have to flip the inequality to basically account for the fact that these two numbers have flipped to other sides of 0. They flipped to the other side of our sort of benchmark for measuring numbers. And when you flip them, you get that -4 is now smaller than -1. So that's the sort of visual way to show why that inequality sign is flipping when you divide by a negative number. And it's because the numbers that you're comparing are flipping over 0 when you divide by -1 or multiply by -1, which means that we need to flip their order when comparing them with greater than or less than symbol. So now that we're through that, really, as long as you can catch flipping the inequality when you have that negative, then we're golden. We can do any problem just like how we would solve any other equation, any other linear equation. So here in this example, we're going to solve the inequality, we're going to graph the solution on a number line, and we're going to write the solution in interval notation. So to solve this type of inequality, well, we need to group the y's together, the like terms. So I'll subtract -11y from each side. 6 minus 11y is -5y. And we have is less than or equal to 17. Now we're going to have to divide by a negative value. So we're dividing by -5. And when we do that, we're going to have to flip this inequality. So we have y is greater than or equal to -17/5. Now this is the solution to the inequality, but we were asked to also graph this on a number line and write it in interval notation. And we can do that. So we put our number line down. We have -17/5. It's somewhere to the left of 0. Let me draw that number line a little better. And we know that y is greater than or equal to this value. So it's filled dot and then moving over towards the right and on and on and on. And we can also write that in interval notation. And it goes to positive infinity. Now here's a tip. When solving inequalities, it's usually easiest to collect the variables on the side that will make the coefficient of the variable positive, because it means that if we don't have to divide by a negative number to simplify our equation, then we don't have to worry about flipping the inequality. Sometimes, like in that last problem, it was just easy to move that -11y over to the other side. It made sense to do it that way. It was efficient, but we had to remember to do the flip. In this example, I'm going to show you that if there's a bit of choice about rearranging this inequality, we might as well do it so that we have positive coefficients with our variable. Let me show you what I mean. So we're going to solve this inequality. To do that, we'll have to multiply or expand this brackets so that we can group like terms. So 3 times p, and then +3 times -12 is -36. It's greater than 7p minus 28. So on the left-hand side, I'll group 8p and 3p, so I have 11p minus 36 is greater than 7p minus 28. And which do I want to do? Do I want to subtract 11p from each side, or do I want to subtract 7p from each side? Well, based on this tip, I'm going to recommend that we subtract 7p from each side so that we have a positive coefficient after doing that. And I'm also going to add 36 to each side so that I'm grouping the constants and I'm grouping the p's. So 11 minus 7 is 4p, and that's greater than, then I'm adding negative 28 plus 36, that's 8. And now when I go to do this division, 4 divided by 4, I don't have to worry about flipping the equal sign because I chose to subtract this negative 7p on this side, which kept my coefficients as positive. So it's just a tip to keep things simpler so that it just reduces the possibility for errors if you take that strategy. There's one more math tip we want to give you, and that's when you're solving inequalities with fractions, you can clear the fractions before solving. And you've probably seen this technique. We've used it before in this course, and it's also something that you might have seen earlier. But we just multiply everything in the equation, everything on each side of the equation, by whatever it is that eliminates the denominators. So in this case, we have to multiply by 24 because that will clear the denominators on the left-hand side. And if we multiply by 24 on the right-hand side, it will also eliminate the denominators. So you have to make sure to multiply 24 into each term on each side so that our inequality is remaining balanced, just like an equation. So 24 times a third, we get 8a minus 24 times 1/8 would be minus 3a. And then we have greater than, well, 24 and 24 would cancel in this first one, so we just have 5a. And then 24 times 3/4, I'll do this off to the side. Well, 24 and 4, we could divide out a 6 from each. So 3 times 6 is 18. So now we have this inequality, which looks a lot simpler to deal with, to combine like terms, because we've eliminated all those fractions with some multiplication. And again, just one more strategy that you can use to make your life easier in these types of problems. I will leave solving the rest of this inequality to yourself, but I just really wanted to show you that trick for clearing the fraction.